Hello students, this is Karthik, your maths tutor, heartily welcoming you all to Vista's Learning. What is Vista's Learning? Vista's Learning is an online education platform where we strive to deliver quality education for all. So in today's session students, we will be continuing from wherever we have stopped in the previous session. So in the previous session, we saw what is matrix, types of matrices. Okay, apart from that, we saw what are the operations on matrices and equality of matrices. So this is what we saw in our previous session. In today's session, we'll be seeing some properties which are based upon operations of matrices. So operations of matrices is already finished, right? So what are the operations on matrices? Addition, difference of matrix, multiplication of matrix, and scalar. Like when a scalar is multiplied with the matrix, so that was also one of the operations on matrices. So today's class will be seeing the properties based on those operations. Alright, so let us begin with the session. The very first slide, okay, we have properties of matrix addition. So what are the properties of matrix addition? The very first law which we have here is commutative law. So what does commutative law say? States matrix A with the order m cross n, okay, when it is added with matrix B of the same order. So whatever this order, whatever the A matrix is having the order, with the same order matrix B m cross n is added. So this will always be equal to what? Matrix B of order m cross n plus matrix A of order m cross n. Which means addition of numbers is always commutative. So for example, so here we have taken matrices, right? So let us consider only the numbers. The same thing is applicable for matrices as well. Understood? So what are the numbers here? Here we'll take some 3 plus we'll take some 7 here. Is this equal to 7 plus 3? Both are equal, right? 10 will be equal to 10. Means what? Addition of numbers are always commutative in nature. So the same thing is applicable for matrices as well, correct? Because in matrices, how is the operation of addition carried out? Addition is carried out such that the corresponding elements of two matrices are added up together. So for example, you can take one example for A like this. A is equal to 1, 0, 0, 1, okay? And B is equal to 1, 2, 1, 1. So A plus B, whatever the sum we get of these both matrices must and definitely will be equal to B plus A. Why is that? Because addition of numbers is always commutative in nature. So therefore, the commutative law is applicable for addition of matrices as well. Okay, moving on to the next one. Associative law. So same thing students. Now let us consider matrix C here as well. So matrix C will consider 1, 1, 1 and 1. Okay, so this is a matrix, right? Now let us see with the numbers. Okay, 3 and 7 we took. Let us take another number 4. Let this be equal to A, let this be equal to B, and let this be equal to C. Now what is associative law? A plus B plus C, this should be equal to A plus B plus C. Substitute the number students. 3 plus B is nothing but 7 of plus C is nothing but 4, which is equal to A is again 3 plus B is 7 plus C will be equal to 4. Correct? So this would be equal to 14 and this is 7 plus 4 is 11, 11 plus 3 is again 14. From here what can we tell? Addition of numbers or the operation of addition in between the numbers is satisfying the associative law. What is associative law? This is the associative law. What is commutative law? Commutative law is given like this. A plus B equals B plus A. So this is the commutative law. This is the associative law. So for example, see I have written 3 matrices here. You can try this students. Okay. So I am only explaining with the help of numbers. So you can try this with the help of matrices. I have written the examples here. So check A plus B of plus C. That will definitely be equal to A plus B of B plus C. Understanding? So addition of matrices satisfies commutative law. Why? Because the numbers satisfy, addition of numbers satisfy commutative law. As well as addition of matrices also satisfies associative law. Why? Because addition of numbers also satisfies associative law. Understanding? Moving on to the next property of additions. Okay, it is called as existence of additive identity. Now, we have 3 here. What should be added in this blank such that we will be getting 3? See the statement, additive identity. 3 plus what is equal to 3? Obviously the answer is very simple. The answer is 0. So what do we consider? We consider 0 to be as a additive identity in addition. So similarly we have a multiplicative identity, which means 3 into dash equals 3. 3 into dash equals 3. What should be filled in this blank? 1. So therefore 1 is called as what? 1 is called as multiplicative identity of numbers. Means any number you multiply with 1, we will be getting the same number. Very similarly, any number you add with 0, you will be getting the same number. So therefore what, students? 0 is called as what? An additive identity. Now here we are talking about matrices, right? So what is the additive identity? Existence of additive identity in matrices means there is a matrix A here, okay? There is a matrix A plus of order m cross n, let us take. This is added to some other matrix such that we will be getting matrix A only of the same order m cross n. So what must be added here, students? Of order m cross n. So when this is added with the null matrix of the same order, then what will be our final answer? The final answer will be the same matrix, whatever you have considered. So this is existence of additive identity in matrices. Understanding? So for example, let us take A is equal to 1, 3, 7, 1. Okay. And what is our O, students? That is nothing but null matrix. Same order, 0, 0, 0 as well as 0. So when you add these both matrices, okay, corresponding elements are added. What we'll be getting? We'll be getting the same A matrix when we add these both matrices, which means existence of additive identity is nothing but the null matrix. Understand? Okay. Moving on to the next property of addition of matrices. Existence of additive inverse. Now this is additive identity, right? So 3 plus 0 is equal to 3. What is this additive inverse? 3 plus what should be added here such that we'll be getting 0. What should be added in this blank, students, or what should be filled in this blank? Very simple, right? If we are getting 0 here, then it must be minus 3. So plus into minus will become minus again. 3 minus 3 will be equal to how much? 0. Understanding? So therefore what is additive inverse here? Any number, the opposite sign of that number if it is added, okay, then we'll be getting what? A 0. In terms of matrices, students, how do we define? Matrix A of order m cross n, if it is added with the same order m cross n, okay, same order m cross n, but it is minus A this time here. Very similar to this, see in the bracket we have minus 3. So 3 plus of minus 3 is 3 minus 3, which is equal to 0. The same thing is applicable here as well. Matrix A of order m cross n plus of negative of this matrix of the same order. So this will be giving us what? 0. So therefore what can we tell? Existence of additive inverse is nothing but negative of the given matrix. Negative of the given matrix. You can consider the same example here. A is equal to 1, 3, 7, 1. What is the negative of that, students? What is minus A equal to? Minus A will be equal to minus 1, minus 3, minus 7 and minus 1. Now you add the corresponding elements, what will be your sum? When you add the corresponding elements of A and minus A, you will be getting the sum as 0. Okay, so this is nothing but what? Existence of additive inverse. So these are the 4 properties of matrix addition. So remember this point, students. So in the previous class we saw the operations, right? In this class we'll be seeing the properties of those operations. The first property of addition. Under that we have 4 properties. The first one is commutative, second is associative, third is existence of additive identity, and the fourth one is existence of additive inverse. So I hope you have understood this. Moving on to the next property. Okay. So the next one, what do we have is properties of scalar multiplication of matrix. So I have already explained you what is scalar multiplication of matrix. Very quick recap. If K is multiplied with the matrix A of order m cross n. Okay, so let us take K of A11, A12, A21 and A22. So this will be equal to KA11, KA12, KA21 and KA22. So what is happening here, students? This is what? A scalar. Understood? That is a scalar. So when a scalar is multiplied with the matrix, that scalar gets multiplied with each and every element or entries of a matrix. That is called as what? A scalar multiplication. So this we had studied in the previous class itself. In today's class, we'll be seeing the properties of scalar multiplication. Only two properties are there. So the very first one is, if K is multiplied to the sum of matrices, okay, let us consider A equals 1, 0, 1, 1, okay, and B equals 1, 1, 0, 1. Now, if you add these both matrices, you will be getting a sum of matrix. Okay, to that sum of matrix, if we are adding or multiplying, if we are multiplying a scalar K, so that will be equal to what, students? Actually, K of K dot A plus K dot B means K multiplied to matrix A and K multiplied to matrix B. Understanding? So here quickly we'll do. So see here, A and B we have written. What is A plus B, students? A plus B will be equal to 2, 1, 1, 2. What is now K of A plus B? K of A plus B will be 2K, K, K, 2K. Correct? So this, whatever sum we got here, okay, whatever sum we got here, this will be equal to what? K of A, K dot A plus K dot B. What is K dot A, students? So this multiplied with K, so it will be K0, KK plus K dot B. So that will be KK0, K. Add them both, K plus K, 2K, 0 plus K, K, K plus 0, K, K plus K, 2K. A very quick proof for the very first property of matrix multiplication. So like this, you can consider your own examples and check out whether these properties are satisfying or not. According to my knowledge, 100% these properties will be satisfying. Alright. So the first example I have written here, the first property with a very small example. So this has been proved. Okay. The next property of matrix multiplication. So the scalar multiplication. So K of K plus L of A. Now here, K was a scalar, right? Here also K is a scalar. L is also a scalar. So two scalars, addition of two scalars when we multiply with the matrix A. So that will be equal to what? K dot A plus L dot A. Understanding? So again you can take an example. Let K be equal to K only, or let us take 1 and L be equal to 3. So 1 plus 3 of matrix 1 0 0 1, 1 0 1 1 only will consider. So this is equal to what, students? This is becoming 4. 4 scalar multiplied with this matrix will be getting 4 0 4 4. Correct? What is this? This is our LHS. K into A, 1 into A. 1 into A is 1 only. So additive multiplicative identity 1 0 1 1 plus 3 into A. L is nothing but 3, right? So 3 into A will be getting 3 0 3 3. Add them up, corresponding elements, you will be getting 4 0 4 4, which is our RHS. So therefore what can we tell? Our LHS is equal to RHS. Therefore the second property of scalar multiplication is applicable and valid on matrices. Understanding, students? Moving on to the next property. Properties of multiplication of matrices. What is the very first property we saw in today's session? Properties on matrix addition, that is associative, commutative, existence of additive inverse and existence of additive identity. The second property is what we saw as properties of scalar multiplication of matrix. Now the third one, properties of matrix multiplication or multiplication of matrices. So here we have three properties. So the associative law for any three matrices A, B, C we have. So you see the students, AB of C must and should be equal to A of B plus C. So again, you can take some examples. A is equal to this matrix, B is equal to this matrix, and C is equal to another matrix. You can assume your own matrix, okay, preferably of order 2 cross 2, and you can check whether this property is satisfying or not. What is happening here? There is matrix multiplication, okay, and what is happening between this and this? Again, we have matrix multiplication. So matrix multiplication, how do we multiply? Okay, we have seen in this previous session, So you can just check out whether this property is satisfying or not. So the very first one, what do we have? Associative law. AB of C is equal to A of B plus C, or A of BC, whenever both sides of the equality are defined. Means equality are defined means what? Orders of A, comma B, comma C are defined. So what should be the order if we have to multiply two matrices? So two matrices we have to multiply, right? So the columns of the first matrix should be equal to the rows of the second matrix. So that is nothing but how do we represent that? M cross N of matrix A, and here we'll take P cross Q order of matrix B. P should be equal to N. Understanding, students? P should be equal to N. Then we can do what? Matrix multiplication. I hope you remember this. Okay, the number of columns of A must and should be equal to the number of rows of B. If this criteria is satisfying, then only we can matrix multiply. Understanding? Okay. So this is our associative law. Moving on to the next one. Next, which law we have? Here we have the distributive law. So for three matrices again, A, B and C, now we are doing what? Addition. Okay. So here we are doing addition. Here also we are doing addition. Also we are doing what, students? Multiplication. So see here, A, B plus A, C. We are distributing matrix A both to B as well as C. Same thing here. This C we are distributing to B as well as C. So this is what, students? This is our distributive law. So A plus B of C is equal to AC plus BC, or the first one, A of B plus C is equal to AB plus AC. Again the same thing. Okay, you can assume some matrices of your own choice for A, B and C and check out whether this property is satisfying or not, and it will definitely satisfy. That is our second one, distributive law. First one, associative law, and the third one, existence of multiplicative identity. Multiplicative identity, students. So what is multiplicative identity in numbers? 1. In this, so 1 is in numbers, right? So what is in for matrices? We have a type of matrix which is called as identity matrix. Correct? Identity matrix. So when we are discussing about the types of matrices, we had come across this term, identity matrix. How is identity matrix defined? Identity matrix is defined as the principal diagonal is 1, 1, whereas the other elements are 0. So this is our identity matrix. So in matrix, identity matrix is considered as multiplicative identity. Why? Because any matrix multiplied with this, okay, we'll be getting the same matrix again. Okay, so we'll see here. The existence of multiplicative identity for every square matrix A, okay, square matrix A, there exists an identity matrix of the same order. So if A is 2 cross 2, identity matrix is also 2 cross 2. If suppose A is 4 cross 4, identity matrix must also be in the order 4 cross 4. Of same order such that IA, multiplication of identity with A, which is nothing but equal to AI, this will be equal to what? A. See, very similar, students. Let us take A is equal to 7 here. Okay, in terms of numbers, into. What is multiplicative identity for numbers? 1. 7 into 1. What will be getting? 7 ones is 7. The same thing is applicable in matrices as well. So for example, identity matrix I have written here. Here you can consider matrix A is equal to 3, 2, 3, 7. Okay, you can consider this as A. Consider this as I. Okay, take these both things, see whether this is satisfying or not. Okay, matrix multiply A and I here, see whether this is satisfying or not. Definitely it will be satisfying. Again, you have to do what, students? Matrix multiplication. Okay, IA is equal to AI is equal to A. Now we shall verify these properties by examples. So examples will be seeing a very small example of the third property will be seeing, students. Okay, the same example will take as I have written there. A will be taking it as 3, 2, 3, 7. Okay, so 3, 2, 3, 7 dot. I will be taking it as 1, 0, 0, 1. 1, 0, 0, 1. The very first thing what we have to see here is, can we multiply these both matrices? Check the order. The order of this is 2 cross 2 and the order of this is 2 cross 2. Are they both same, students? The number of columns here are 2. The number of rows here are 2. Number of columns is equal to number of rows. Therefore, we can multiply. What are these both numbers representing now? These both numbers are representing the order of product. Means when we multiply these both matrices, what will be getting? We will be getting 2 cross 2. That is order of the product. Okay, so let us open this bracket 2 cross 2 here. Now matrix multiply. First row into first column. 3 into 1, 3 plus 2 into 0, 0. First row, second column. 3 into 0, 0 plus 2 into 1, 2. Okay. Second row, first column. 3 into 1, 3 plus 7 into 0, 0. Second row, second column. 3 into 0, 0 plus 7 into 1, 7. Which is equal to, what is the order here? 2 cross 2. So this is equal to what, student? 3 plus 0 is 3. 0 plus 2 is 2. This is 3 and this is 7. Is this the original matrix whatever we had considered? Correct. These both matrices are same, right? Which means what? What is the additive identity in matrix? The additive identity in matrix is nothing but the identity matrix. Sorry, not additive identity. Multiplicative identity. Multiplicative identity in matrix is nothing but called as what? An identity matrix. Why? Because any matrix you multiply with the identity matrix, you will be getting the same matrix as outcome. So it's very similar like this. 7 into 1 equals 7. Understood? So moving on to the next one. So these are the properties of multiplication of matrices. The next what we are going to see in this slide is about symmetric matrix, and here we will be seeing skew symmetric matrix. Once we finish these both things, on this side we will just have to look at, okay, one second. Here we'll be seeing what we have done in today's class as summary. All right. So starting with the very first one, symmetric matrix. Okay. So this where we have studied again. We have studied this in types of matrices. Correct. So in types of matrices, we came across a matrix which is called as symmetric matrix. And what is symmetric matrix? How do we identify symmetric matrix? Okay, ignore the principal diagonal, let the principal diagonal be however it wants to be. Apart from principal diagonal, the other elements must be mirror images of each other with same sign. Means, here what we can tell, principal diagonal is line of mirror. Principal diagonal is line of mirror. If suppose you keep a mirror on the principal diagonal, whatever elements are below the principal diagonal or above the principal diagonal must be equal above or below respectively. Okay, so for example, small one, 1 minus 7.2, 3, 3. See, cut this. Above you have 3, below you have 3. Same number, same sign. Which means what, students? It is a symmetric matrix. So this is just by looking at the matrix you can tell. But how do we prove it mathematically on a paper? So for symmetric matrix, the formula or what you have to remember here is matrix A will be equal to transpose of A. So here we are getting a term called as transpose. So what is transpose of a matrix, students? So transpose is denoted by a dash. Sometimes transpose is also denoted by A to the power of T. Okay, what is this transpose? writing the rows as columns and vice versa. And what is vice versa, students? Writing the columns as rows. Okay, so A transpose means what? Writing the rows of a matrix as column, and vice versa, writing the columns of the matrix as rows. This is called as what? Transpose. So we'll take this, let us consider this as A. Okay, so A is equal to this. What is A dash, students? A dash, write this row as column 1, 3. Write this row as column again 3 minus 7.2. So this is our A dash and this is our A. Are they both same? 1, 3, 1, 3. 3 minus 7.2, 3 minus 7.2. Therefore, A equals A dash. Then we can tell what, students? Then we can tell that the given matrix A is a symmetric matrix. So this is just to prove it on the paper. Okay, A equals A dash. Another point, so this is a very important point. Remember this point to be remembered. Apart from this, if any matrix is given for you which is not symmetric matrix, so for example, let us take matrix B is equal to 5, 1, 3, 7. All the elements are different here. Is this symmetric matrix? No. How? Ignore the principal diagonal. The other elements must be mirror images, but they are not. Here we have 1 and here we have 3. So therefore, students, it is not a symmetric matrix. Now, if you want to convert this matrix into a symmetric matrix, okay, how do we do that? So what we have to do here is again use another formula. So see, this is the very first point to be remembered, right? The second point to be remembered under symmetric matrix is you have to consider, let P is equal to symmetric matrix, which is equal to 1 by 2 of B as it is, matrix B plus B dash. So if you perform this operation on the given matrix B, what will happen, students? That given matrix B will get converted into symmetric matrix. Okay, you can try this. B transpose, you can find out, right? So I'll write here. What is B transpose? B transpose is 5, 1, 3, 7. Okay, add these both matrices, multiply it with the scalar called as 1 by 2. What will be P then? P will be a symmetric matrix. So this is point number 2 to be remembered under symmetric matrix. So these both points are the points to be remembered. Alright, moving on to the next one, skew symmetric matrix. So here we had what? A is equal to A dash, right? In skew symmetric matrix, if A dash is equal to minus A, then that matrix is called as what? A skew symmetric matrix. So this is mathematically defined. But how do we identify skew symmetric matrix? So for example, 1, 9, 4, minus 4. Let us consider this as to be as A. Okay, so this is our A. We'll see what is A dash. A dash will be equal to 1, minus 4, 4 and 9. So this is our A dash. A dash is equal to minus A. So now A dash will write as it is. A dash is equal to minus of A. So minus of A, what will be getting? A dash is equal to minus of, what is A matrix? 1, minus 4, 4 and 9. So this will become A is equal to minus 1, 4, minus 4, minus 9. Okay, so see this, these both elements are mirror images of each other but with different sign. So minus are also coming here, right? Minus and minus, minus of A. So if A dash is equal to minus of A, then we can call that matrix as what? A skew symmetric matrix. And what is the formula, students? So for P is equal to, we consider it as a symmetric matrix, right? Here we'll consider Q as the skew symmetric matrix, and how to express any matrix into skew symmetric matrix. Okay, that is by 1 by 2 of A minus A dash. Understood? So if A is given like this, okay, which is already a skew symmetric matrix, so let us take B here then. B minus B dash. So consider the same matrix here. Okay, B, whatever matrix we have got. So B dash you find out. The only difference is for symmetric matrix you have to add here, while for skew symmetric matrix you have to subtract. If you do the subtraction, okay, skew symmetric matrix, you will be converting the given matrix into skew symmetric matrix. So 2 points to remember in skew symmetric matrix is A dash is equal to minus A, number 1, and this is the second point. Q is equal to half of B minus B dash. Understood? Now what we'll see, students, at last we'll be having a very quick look at the summary, means whatever we have covered in today's class. Okay, we'll quickly have a quick summary on that. Okay, so what we started with today, we started with properties of matrix addition, correct? So properties on matrix addition, first one. Properties on matrix scalar multiplication of matrix. Third, we saw properties on matrix multiplication. Fourth, we saw symmetric and skew symmetric matrix. So matrix properties on matrix addition, what are the laws we saw there, students? Associative law, commutative law, existence of additive identity, and as well as existence of additive inverse. So this is what we saw in matrix addition. Next, properties on scalar multiplication of matrix. So what are the things we saw here? So two properties we saw, correct? K of A plus B, which is equal to Ka plus Kb, and the next one is K plus L, where both are matrices of A, which is equal to Ka plus La. So this is also true. Properties of matrix multiplication, three properties we saw: associative, distributive, and existence of multiplicative identity. So these are the three properties which we saw in properties of matrix multiplication. The very last thing what we saw today is symmetric and skew symmetric matrix. So symmetric, how do we remember? A dash is equal to A, and skew symmetric is A dash is equal to minus of A. How do we convert the given matrix into symmetric matrix? We will be considering that P is a symmetric matrix which is equal to 1 by 2 of B plus B dash. To convert the given matrix into skew symmetric matrix, instead of plus, we'll be using what, students? Minus sign. So this was for today's session. In our next session, we'll be continuing with our next topic as well. Until then, please do like the video, share and subscribe. Thank you, students.